I just want to be able to read it. Oh, it's up there. Never mind. Okay, we're good. We got a second, I think.
Do we start on the hour?
Yeah, same thing. Give some people some time to get in. Yeah, feel free to jump in. Helping with doing all the different things. This is what I actually printed the sides for, so I know what I'm talking about. I'm like, all the rest of the things I just made it up. This is my concept of what's coming. Yeah, feel free to interrupt me, especially when we're not miking. Oh yeah, we did this thing. Yeah, exactly. Not doing anything. Half the time we're in the lounge just yapping. I don't know. It's useful yapping. I mean, we're not being good if we're talking around 12. It's a lot of yapping.
It's a big room.
It's a weird room for it.
Yeah, it
I feel
is.
like they should have put it in a different room.
Oh, thank you. I need that. Yeah, it's my Thunderbolt 2/main display projector. Yeah.
Just an empty. People standing, if you want to find a seat before we get started, there's some empty chairs around. Yeah.
Well, I have my hoodie on. So.
All right. Welcome, everybody. It doesn't look like the rooms have microphones, so we're going to try to be loud. Feel free to ask us to repeat something if we mess something up.
There's microphones in the back.
Are there? We were. Does anyone know?
Right next to where that ear is.
We had so many people. Okay.
It's okay, Alan. You have a good teacher voice.
All right. We can make it work for a bit. All right. So while Amelia's doing that,
Oh, they definitely are.
I'm Alan Gregory. This is Witchery. That's Mary. We're the technical mentors for Spectrum Theater 7. We're going to talk today about kind of our process that we've developed over the last few years, going through the first week of build season, and what that looks like for us and how that sets us up for a successful season. Part of our goal in that first week, it's 11 days because we do our design recaps on Tuesday. So our basic goal is that second design recap, the second Tuesday of the season, is to have our robot architecture laid out. Testing. Hey, it works. Okay. I can be a little bit quieter. So through that, the robot architecture we're trying to find is the one that will allow us to have a successful season. Our rough goal for that is to have an opportunity to win District Champs in Einstein. It's really hard to have the goal to actually do it, but we want to be, the term I often use is in the mix. That means somewhere, depending on the event and everything, one of the top couple alliances, few alliances, somewhere in there depending on the event. And our robots performing at a high level at those events when we can. A lot of teams, especially now that we don't have bag, as much as it feels like a sprint, some part of the season is a bit of a marathon, right? We know it's long. It starts on kickoff. It takes another 16-ish weeks before we actually finish up at the World Championship. It's a really long season. You're developing your robot the entire time through that. Ideally, you want something that you call a robot much, much sooner, but the robot is taking that whole time. Finding that right architecture that allows us to develop and iterate throughout the season is the goal of that first week. And then we get to work actually doing the CAD, getting the build, doing all of that stuff. Okay, when we say architecture, what does that mean? The robot architecture is of the same reason why in our earlier presentation where we were talking about the build blog, when we say Citrus has the same robot as us, their robot is entirely different and in no way actually the same, but it has a very similar architecture. The mechanisms all interact in the similar way. We're accomplishing and solving the problems in a similar style. The materials, the build, the exact measurements are all entirely different, but the architectures are very, very similar. The stool falls. Okay. It's the model or the sketch. It's the concept of the robot, not the actual implementation of the robot. We have rough space claims. We know the launcher's at the front, the intake's at the back, the elevator moves up and down to be able to score in the amp. All of those things are similar with this one that we eventually settled on for this year, but there's a lot of different ones. There are a lot of similar ones throughout 2024 that we can talk about. We seem like 2056 OP and Buck's Wrath had very similar robot architectures. They're basically the same architecture. They did the same. Their launchers pivoted in the same way. Intakes work the same way. Climbs were the climb can be a little bit different, but a lot of the other things can be the same. Okay, so what we're going to go through and kind of what we're talking about is maximizing. Any one of these I could probably do like 45 minutes to an hour on, so we're going to try to not go a little bit fast, but feel free. We'll have questions at the end. They're going to interrupt me when I forget things. So the first part is we're going to talk about preparing for kickoff. We're going to talk about what we actually do on that kickoff day, building field and being able to actually finding a way to mimic the actual field that the robot's going to have to compete on in ways that you're going to be able to test your systems. We're talking a little bit about prototyping. I have a whole nother hour plus presentation on prototyping that exists online, so I'm going to try to make sure that one's short. And then a big part of it's going to be understanding the game, what we often call strategy, and then a little bit about decision points and how we like kind of get that first week timeline going. Okay, so in a few days, it is going to be the exact midpoint between the end of World Championship of 2024 and the kickoff for season 2025. Yeah, we're like 3 days away, something like that. So at this point, we are well into preparing for 2025 on Spectrum. Like we are doing a whole lot of things with that goal of knowing kickoffs at this point basically around the corner for us. It's still months away, but we know if we're not working now, it's going to get to us way too soon. So we're doing as much preparation as we possibly can so that when kickoff comes, we can be working on the things that actually matter to solving the game and not trying to figure out, oh, where is the belt sander belt, because those are all gone and we broke that one and now we don't have spares. So we are figuring out what spares we need for tools. We're figuring out what material we know we need. We're trying to make every decision we can without actually knowing what the game is yet prior to kickoff. Every decision, every resource thing we can do, whatever we need to maximize, getting people trained, recruiting new students, getting things cleaned, getting things organized, anything that's worn, all of that stuff we're trying to do now, because that's time that we don't have after kickoff, because RC said it earlier, time's the resource that we can't create once kickoff starts. We all only have that like 16 weeks till the Worlds. And so we're trying to do whatever we can to prep as much as we can before kickoff. Ideally, you have some sort of plan for what your season's going to look like. We don't have it down until like this day we're doing this, but we have a rough idea of what we're planning to do. We know roughly what the kind of rough schemes of like, hey, we want to be able to have an alpha robot built at this point. We want to be able to have a practice robot kind of built here. We want to have some idea of how we're going to play the game. All of those things are kind of laid out for us, but they're all going to move. They're all going to change based on the game, based on where we're at. New things. We know that we're not trying to rigidly say and be like, oh, we don't have the robot designed here. We have to pick a design today. That's what we said. Like, hey, if we're not ready, we can keep pushing. We just know that that moves other things, or we know we have to catch up somehow back onto schedule. Yeah, assume a lot of the decisions will change. Like if the game's something wild, like they throw 2009 at us and we have a weird floor, right? We have 2015 and we're not running into other robots. a lot of things going to change. The decisions you made before, you're like, oh, we were absolutely going to do this, and we're going to make our bumpers this way. Like maybe you don't have bumpers. I don't know. Maybe you don't have traction, whatever it doesn't have. Like FRC can throw curveballs at you, but there's a lot of things you can make assumptions on. I've been doing it for long enough. A lot of the games are similar enough. We're probably playing on carpet, but maybe not. So yeah, studying past games, studying past robots, all of those things, you can make informed decisions. Roughly when you see the game, you kind of have some idea of like, oh, there's another climbing bar. I know lots of ways to hook onto a bar and pick a robot up off the ground. It's been done dozens of times, hundreds and hundreds and hundreds of times. So you already have some of that stuff going for you. Anything else on prep? I'm trying to think if I missed anything.
So for the prep time, this is also a good time to, I guess, evaluate your space, your processes, what worked, what didn't work, and what's going to be changing. If you're getting any new tools and resources, how you can adapt your space to fit those. And if there was something that didn't work that could have been optimized, start introducing those changes now so that they're implemented and you're used to them by the time that the season starts.
Yeah. Other things, if like you're able to like build a off-season robot and things with the students that you're going to have for 2025, that's really good. If you can get them in, if you can build an entire prep simulated season, doing any sort of mock kickoffs, whatever you need to do to get your students ready, and you can do ahead of time. One of the things we do like kind of right before is we'll go through and read the previous year's robot rules. The robot rules don't update all that much. We'll read a lot of the evergreen manual beforehand. We can do all of that before kickoff. And so when the first time the new students see a manual should not be on kickoff, right? We have dozens of manuals. They can read all of them right now. So like you can introduce all of those rules and things to the team. So none of it's really a surprise except for the new game. All the other stuff should already be pretty much a known quantity. Yeah, some of the other things we'll even prepare is like we know we're going to need some amount of 2x4s and wood and things. Like we'll pre-purchase some of those things for the field build. Anything that we can get ahead of time and get ahead of, we will try to do before we actually get to kickoff. Okay, on kickoff, almost everybody has a slightly different way they handle kickoff with their team. That's great. Kickoff's not the most important day of the year. Like your season's not set on what you do on kickoff. You could have a kick, like if some team couldn't do anything on kickoff and they just all read the rules online one day, that's a totally fine way to start the season. Whatever needs to happen for you to get your students to understand and have a good concept of the game, be motivated to be pushing through the next 6 to 7 weeks of robot building, is really what you need to do. You know your students and your community and your mentors way better than I do. So whatever you need to do to get them excited and get them ready is kind of what you need to do. So some years it'll be different based on where our team is. We'll have, we've played like the human game where you kind of tape out the game and you have your kids play it with just whatever game piece you have or mock game pieces or whatever you need to do. What we try not to do is try to do anything close to like design the robot on day one. We just don't know and understand the game anywhere near enough from only seeing it for a few hours to be able to be like, oh, this is exactly what's going to work and this wins Einstein. Like you just don't know yet. There's so many things that just mulling it over, reading the rules more, seeing the robot in 3 days or whatever, we'll go through some of that. But there's so much information you'll get in the next 11 days, 10 days, whatever, that informs your choices so much more than just the kickoff animation and like the field tour videos or whatever you see.
And as far as reading the rules goes, everybody should be doing it. Like whether this is the first time you're a freshman, it's your first time seeing an FRC game, read the rules. It helps everyone. Just lets you be more informed going into once you start talking about the design.
Yeah, similarly, it's not just read the rules. Like we used to harp on that a ton. We're just like telling every team to read them, but you don't necessarily want just your students just reading them, sitting there, or however they're going to do it. It should just be second nature for especially that first week that you're talking about the rules regularly. Like, so anytime something comes up, if we're in the middle of building the field or if we're talking about the robot, we're like, oh, we can't do this because of a rule, and someone pulling up the manual and reading out that rule because we know what that one is now. Or anytime somebody says something, we're like, are you sure that's right? It's very quick on the team to pull up the manual and read through the rule again to make sure we know what it is. And it just gets ingrained really quickly what the actual rules and the ones that really matter are. for the game. We're like, oh, we can't do this because podium's protected. Okay, we know that. Is the other thing, is there a podium over there? No, we don't know exactly where those things are. And you figure out a lot more of the game as you discuss and talk about it over and over and over again.
Yeah, like especially even us that try to like read the rules very, very well. There'll be times like 3 days into a season where we've made assumptions about the rules because of ways it's been in the past, or even of ways you read the rule that like we think about it for a second. We're like, wait, that doesn't seem right. We go back and reread it, and it completely changes our understanding of the game. Like just like small specific wordings of specific rules. And so really harping on like what does the rule actually say, not what is it like trying to say, and like understanding what it's meant to do as well are very important.
Yeah, similarly, there's going to be some stuff that we know is going to come out when the first Q&A stuff starts coming out or the first team updates. So some of those are like, we'll take notes and be like, hey, if this, how exactly does this work? Where it's a little confusing how this interacts with this. Did FRC get this right? Maybe HQ needs to go and change this, or we need to Q&A it if it's not quite getting to what we think it is. The game's been pretty good in recent years where the kickoff game has been pretty close, but even this year they did the whole 4-note thing in AMP, which changed a lot of people's ideas pretty quickly. So you have to be a little bit open-minded. Another reason not to design on game one is the rules aren't even set in place on day one, right? You have a little bit of time to get the actual game that you're going to play by the time they actually release stuff on that Tuesday or Thursday of the first team update. Okay. So one of the things we do instead of trying to design the whole robot is we'll try to start going through and thinking about what are the trade-offs and decisions we need to be making, or that any team can be making about a robot they're going to build. So a lot of times they may seem obvious. So like when I saw this year's game animation, I was pretty sure a robot was going under the stage. It was pretty obvious, but we still put it on there because there are likely going to be some amount of successful robots that are tall. There ended up being some successful robots that could be both short and tall, right? They could like flip up and shoot over people. And so those are like ends up being feature things that robots can have that you don't necessarily know and don't need to know which way is better yet, but you can start laying out the like mix of what are these different trade-offs that can all build into a different robot. So like you could go through this list and probably figure out, oh, we made this choice, we made this one, we made that one, and you can get to your robot by like choosing all those different things. Yeah, we don't, that list is definitely not complete. We start learning and figuring out new things, especially as we build the field, see other people testing things. We're adding new things to these like decision lists and these trade-offs, so that as we're talking about different architectures for robots, we go, oh, this is the thing we think makes more sense. We don't think we need a turret, but we do think we need to be able to make sure we can source and ground intake or something, or maybe source could work, it'd be fine, but maybe we only need to ground intake. So you can start making those decisions back and forth. And a lot of times we'll just even devil's advocate some way and be like, what if we only source? Like, what would happen? What does that robot look like? Can you build an elite robot that does that? Because it may make something else interesting, or you may make, oh, maybe I need to prioritize this to be able to do something the way the both the Poos and the Bees had ways that they could source and immediately shoot and things. So you get to a lot of those ideas that you may not even thought of before by being able to kind of mentally play with some of these lists and figure out what happens if your robot can only do one or the other. Yeah, we don't start making decisions on what a robot won't do on day one. We don't know enough yet. There's some things where we're pretty sure. So like the jokingly, like we weren't buddy climbing. I don't think anybody tried this year. Hopefully not. But like actually trying to lift somebody else up this year. But it went on the list. One of the students suggested it, so it was there, and then we crossed it off in the meeting because we were joking around. All right. Field build. So this is one that's probably relatively new for us in the way that we aggressively go after it. But our goal in the last 2 years has basically been to build as much of the field as possible as soon as we can to a level that allows us to start testing quickly and lets us use the prototypes that we need to. So, and with whatever resources we have at the time. So for your team, if that means you don't have a space, you don't have a place to put things, if it's tape on a wall and you can tape out where the amp is and you can tape out where the speaker is, that helps so much in just being able to visualize things. You can hand throw an amp in there. You can, set some things up to be like, oh, wait, the amp can't go under the stage if we also are up putting something in the amp. And so you can see things a lot more once you have a field. So this past year, our day one amp, the students built up, and it was the amp that we still have right now. The speaker was kind of funny. I wanted a speaker day one, and the wood one wasn't looking like it was coming up. I don't remember what the students were. I think you guys were like talking or something. At some point, I was just like, annoyed, and I went and just got a bunch of PVC, and I was like, "We're building a speaker now." And so we just like made some measurements. They were super rough. That speaker is no way good, but it let us sit for probably 30, 40 minutes just throwing notes out of it and realizing, oh, we have to be at a much lower angle and much farther away. If we're farther away, we have to be at a much lower angle. When we're up close, it's super easy to shoot. And so you just learn about the game so much more. Those are things I kind of knew intuitively, but the students got the grasp of it way faster for random scrap PVC that we had sitting in our lab in like 20 minutes. The next day, that Sunday, we got the actual speaker up, and that helped a lot more. And then by day 5, we had our full stage up, ready to be able to do a lot of our climb testing on that, because that was one of our bigger decision points that we knew early on was, do we trap and what does that look like? But we couldn't make that choice without knowing how hard that task was going to be, and we needed an actual stage to do that. Like, we had some concepts of how we thought we could trap, but we didn't know if it was actually possible.
So with the stage in particular, knowing how the chain interacted and pushing up against the backboard and how that pulls the chain away from it to help you raise even more, that's something that, because we've never had kind of a task like that, it's hard to see that and understand it without actually having the physical thing in front of you. And the fact that we were able to understand it and our students were able to as well was a huge help for actually letting us achieve that.
Yeah, that first picture, which you can't kind of see because we're in the middle, but if that prototype is literally just like a 2021 like test chassis with some like 1x1s just thrown on it. I think some gussets. Like, it is not a prototype in any way. It is a robot hanging there, touching the wall, and like, hey, this doesn't fall. Maybe if we make it actually pull up and things, it'll work somehow. So like the first versions of tests and things are a lot of times just getting those visuals in the student's head so they can get that grasp of what they're going to have to make this robot do before they start actually trying to even decide what it's going to do. Practically everyone. Like, there's not anything, nothing else is really going on, right? We've done all the other prep, right? So we have swerves and things. There's a few other times that people are doing something where it's like, oh, we need to like, maybe we'll build a little prototype or something, and there's a couple people off doing that. But the vast majority of people are working on field build stuff while we're also talking about the rules and sketching some robot things or seeing some robot in 3 days video. Like, there's other things going on. There's breaks and things. But the most part, the highest priority is getting the field built.
I think most of us as the technical mentors, if not all of us, were building the field. So it's like there wasn't much else going on.
Especially when we had the majority of the team in the room, we were doing the field build, because it takes a lot of manpower for us. We've attempted to have like some teams are able to have like the parents doing stuff, and it just doesn't. One, you don't have a sense of it, and you have to like repair stuff anyway. And if like some other people built your field, you don't know how to do that. And like, yeah, it's just been a kind of mess when we do it. Having us and the students lead it just gives a better understanding of exactly what we're gonna have to do as much as we can. Most of this is just straight to the FRC specs. We happen to have an actual driver station, so we're able to mount the speaker on top of it, and like use whatever resource you have, right? So again, we've had seasons, our 2014 goal and trust and everything was just tape on a wall, because that's what we could have at the time. And so if that's what you can do, you can make something work. PVC can make a lot of things in each year, in most years. But yeah, we try not to just be like, oh, we'll be able to test at someone else's place. We don't need to have something at home. You should probably have something at home, no matter what it is, even if you have to take down the PVC all the time, just because you can have that thing to test with and visualize with, and it helps your design a lot. Okay. Prototyping things. So the goal of every one of our prototypes is for someone on the team to have an increased understanding of one of the problems we're trying to solve. I've been doing this for 23 years. A lot of times I don't necessarily need to see a ball get picked up by a roller. I've seen it a lot. But the freshmen haven't necessarily seen that ball get picked up by a roller, and it helps them visualize how it works. And so we build that test thing really fast sometimes. But other times we'll like lay out some things and make sure we have some idea of what we're the actual problem we don't understand, something about the game, and the prototype is going to help us get there. Yeah, in this, there's a link to a whole other hour presentation on the different types of prototypes and things we have. We're not going to go through all that. On day 4, we built this little roller one. We have a laser cutter and can laser cut cheap plywood. So it lets kids CAD stuff really fast and throw bearings in it and make things quickly, which is great. For very little money, because this is like $20 a sheet, 5mm underlayment from Home Depot. It's terrible and shouldn't be on actual robots, but it works great for.
It's still on
Hey, IT. Okay. Okay. So yeah, so on that day 4, we were able to build this very, very cheap little box. It had some cheap hex shaft and random compliant wheels in a little spacing grid. And it let us be able to play with a lot of, oh man, there's so many tabs. Okay. All right, so yeah, so we were able to do like the most basic of intake testing with very little, right? We had 4 drills with some 1/2-inch sockets on them. Didn't have motors, had a bunch of kids figure out how to have their hands there at the same time. So again, none of this has to be expensive. None of this has to be hard. And that little thing we kept together the entire season, and we're using it in probably like week 5 or 6 to do some different trap testing at some point. Like it is still together to this day. Like that thing was great. We use it for all sorts of stuff. Oh, did it unshare? Okay, he'll IT will fix it. Maybe because it's his computer. All right. Yeah. All right. So yeah, so that little thing does more than just intake. It was also able to do like some amp tests because we could change the direction of all of those rollers, so we could see what the note did if you passed it through each and every possible orientation through that roller. And so the goal was to solve a lot of different things and understand how the note worked with a single thing that we could build. That was one of my favorite prototypes that we built in a while. And basically you could do it by hand if you needed to, but if you could do it on a router or laser cutter or anything, it's a little bit easier. The climber testing, once we got a stage, this prototype is an elevator that we built 2.5 years ago for a test thing, right? Pre-2023?
Pre-2022.
Yeah, you're right, because we ended up not needing it. So this is even older. So we left this whole elevator together. We took the motors off and stuff, but like we didn't need the tube, so it was able to sit in a closet. And then when we got this game, we were like, oh, hey, we need to figure out how to move up and down on a chain. Let's go grab the thing from the closet, bolt it to that other chassis that we had sitting around from 2021, throw some wheels on it, and we could figure out if we could climb or not. So like as much simple stuff as we can, if we can keep prototypes together and put them on a shelf high up somewhere, so we're not having to build it in that season, the better and faster we're able to do things. Like that thing has a weird intake on it. That doesn't matter. We don't care. We just need it to be able to go up and down. Again, it's powered by a drill. Like we're not trying to build anything fancy this first week. We're just trying to figure out how to understand the game. This one was definitely a little bit more. This is closer to our alpha. I did very bad. I moved all the buttons. All right, there we go. All right, that's some vision stuff. Our program people were testing. There we go. All right, so let's see if we can do this better. All right. So we did actually for this decide this year to fully make this chassis. So we did throw swerve modules on this and started kind of building up what we thought was going to be our alpha robot relatively quickly. Mostly because we knew this like under bumper intake thing was really new. We didn't have a chassis that could do that nicely. Or this was a new belly pan, or is this 2021? This was.
It has the crossbar or 23 for the elevator or for the 2020. Wait.
No, I think that is alpha.
That is alpha.
I think that's alpha. So I think this was a new CAD. The swerve modules came off something else. They were already pre-built. But I think the belly pan was new, and we just bolted that random battery thing on from something else. I'm pretty sure that was already cut. Is it not doing it? Oh no, it is. Okay. So yeah, so this was. No, I think it's the right size. I think it's 20. Yeah, I think it is. Because remember, we had a bunch of discussion on whether we could use an old chassis or if we had to build a new one. But like, it ends up just being some chop sawed tube that was used from some other robot and thrown together. Then this one we did put a motor on because we needed to be able to kind of do what we needed. This board is just an old PDH with a PWM signal generator and a battery. And put a little turn thing on and just push it and like see a note intake. And so we're like, oh, can we actually, this is one of the points we had to decide, like, could we package our intake into this space? And so this prototype allowed us to get here. And this is a little bit closer after we had done some other testing. This is after 95 showed us how to do the Undertaker, their intake style. So we were looking at other teams, like we didn't come up with that. We just came up with being able to put it in the right space. So again, oh, okay. Yeah, so as soon as kickoff starts, we're meeting every day, basically until the last day of champs. So a lot of this you don't have to do because of things like the Open Alliance. You can see a lot of other people testing things and be able to make a lot of judgments from their tests. All of our testing videos go on the SmugMug. A bunch of other teams have testing videos. A bunch of other teams have sketches and things they've shown and learned, and we use all of that stuff too. We're going to talk about in just a second. So again, you don't have to be prototyping at this level, but most of any one of these is not super inaccessible to any team to do. They don't take that long. If you have a CNC router, if you have a laser cutter, some way to be able to take some CAD, make a part. If you have paper templates that you can print out and glue on and drill, you can get pretty close for most of these things. Okay. This is the one that's definitely far more abstract and just takes a lot. And for some teams, depending on like what your resources are and how you want to do things, a lot of people's best option is potentially just to like look at all the RI3D robots, look at all the Open Alliance robots, and decide to build one similar to them, right? A lot of teams around the world, if they just looked at Wyndham's robot and built that, they would have had a pretty good season because that robot was pretty simple to build, pretty easy, and was very, very successful. Yeah, we built one of our other teams built, like our second team built that robot. So for a lot of teams, if you, especially when you're gaining experience, using another design and basing it off something that probably already works and you've evaluated things, you've looked at it, you think, oh, this is pretty good, and I don't have to sit there and do all the sketch work to make your own architecture is a pretty good option for a lot of teams. As you're trying to do your own thing, if you want to, if you're getting to a level where, or if you look at all the other things and you're like, oh, none of these actually really meet our requirements, we think the game's going to be played in a different way, or we think our robot needs to be able to do something else to play it at play the game the way that we want to play it. You have to do a lot more of understanding the game, and then a lot of the work in some form of CAD, either sketches or with Crayon CAD, or some other way that you can actually start playing a lot more with the geometries, seeing what fits, seeing how you're able to package everything into your robot. Yeah, so after kickoff and throughout that whole first week, we are reading the rules multiple times. Like I will probably read it 2 or 3 times, almost full through, and rewatch the field tour videos and things, go look at the field image things that are released, all of the resources that first release, because until we get to see a real field at week 1, that's all the information we really have about how this robot actually has to interact with the field. So we'll go through the field drawings and start looking through like how a lot of things are built. We'll look through the field CAD. So much of the problem set that we have is the field and then the game rules and game piece and things that we have to know about. So the more we understand those, the better we can play the game. Again, all of that we're talking with ourselves and our students a ton about. Like I'll have the whole field CAD up on the projector and be like, oh, look at this. This is how the little serializer works, or this is how the amp actually scores out the back tunnel. It's a little bit different. It kind of goes in at this weird angle. And so all of those little details matter. I know I can't imagine, raise a hand, how many people had trouble scoring in the amp this year at some point when you put it on a real field? Like I imagine a lot. Like it is tricky. There were lots of little lips and things. And so much of that is like, if you can look at the CAD, you can get close. You can't solve everything, but you can at least learn more about how it's built. We'll go through and look at the materials. We'll look through as much as we can and then decide, hey, do we need to get ours built that way? Or can we keep going with the wooden one? How high fidelity do we actually need to make our field to be confident it's going to work on the real one? And a ton of that is just judgment and doing it over and over again. Then sometimes it's like a flip of a coin and just hoping, depending on what resources you have to be able to do it. Okay. Other things that we're doing throughout this game for us is how do we think the game is going to be played at a high level? Either that's whatever level you want to be able to play at, if that's your regional playoffs or district champs playoffs or worlds playoffs or Einstein, you can kind of set the bar for how you think the game is going to be played then. and ideally try to make sure your robot can do that. It's very hard to take a robot that's not quite built to be able to do everything at the speed needed to do it at the Einstein level and get it there just by modifying things. A ton of what we'll do early on, some of the things that we're doing, not just building the physical game elements, is we'll start building sketches of the game elements. So we'll have 2D sketches in CAD so we know where like the goal is. We know the distance away for the subwoofer. We'll know, like, we'll have an amp in there, we'll have a source in there. And so we'll have those sketch elements pretty quickly so that when we have our actual 2D sketches that we're doing to kind of lay out the packaging problem and figuring out exactly how to sketch out our architectures, they can be driven by a lot of those field dimensions for us. The other part of that is then using all the other resources that are available to you very quickly when the season comes out. This is definitely tricky. There's a ton of stuff. Figuring out how to pick out the good stuff is not easy. We share a ton of it with the team. We tell the students to post things when they see something cool and interesting. And sometimes it's just like, oh, all the teams are kind of doing it this way. Is this the best way because everyone's doing it that way, or is there a better way? And you don't always know. Some of it is just you have to. There's a quote, I don't know if it's from, I think it's from a doctor. The good judgment comes from experience, and experience comes from bad judgment. We've had a lot of bad judgment over the years to allow us to have a little bit better judgment now, because we've made a ton of bad choices and had seasons where we were rebuilding things and doing a ton of other things. We're like, oh, we did not get that right. And so we go back and use some of our past experience. We go back and look at past games, talk over things with other people. Like once we're kind of settling on things, we'll send stuff to some of our people that we trust or Slack groups and things and be like, hey, does this make sense? Are we on like way too far gone? And then sometimes you have to decide whether you're trusting yourself or the other people if they tell you no. So a lot of it is just judgment, working with your mentor team and the students as well to be like, hey, everybody cool with this? Is this kind of the direction we want to be going? Is there something that's not anywhere close? And all the things we're talking about, it's not just like our mentors doing this. Like a lot of our actual packaging section stuff this year was all done by our lead student who graduated last year. She was going in and CADing almost all of it. There are a few different ones that I was working with as well, but yeah, there's a lot of it. Yeah, yeah, all of the field stuff was done by her. There's a ton of that. Okay. Anything I didn't get here? No. Yeah. So this one, I didn't really do. Before we do the decision point thing, so the architecture bit, I was trying to figure out how much time we'd have here to figure out how long we could go into this, because this does take a bit of work to figure out how all these sketches and things work. A lot of these lines are where the stage is and how far we need to be able to run under them. These are roughly swerve modules and bumpers and things. I don't know how to get that video going. Can you just like the one under this? Oh, on that side it's fine. So you actually have the whole sketch over there. Yeah, so this is kind of the goal, and this was day 11 when we were pretty happy with where the architecture was, because this solved a lot of our problems and be able to get us to matching up all of those different trade-offs in a robot that we thought we could build, actually build, while still fitting in all the packaging where we were pretty sure it was going to meet weight. We were pretty sure we could actually build it. There wasn't too many super complex things. There's a lot of times where we're trying to figure out, we knew we had to like do this elevator thing back here, and we're like, oh, how much height do we actually need this elevator to get to where we can dump the node out while still being able to climb up and actually get it to go into the trap window or be able to get it to go into the amp correctly. And there were a lot of sketching going on there. We're like, ooh, can we actually do that? Like, how far do we have to bury the elevator to our belly pan to make that actually work? And so a lot of those are little tiny things that could potentially very much mess up your season if you decide to go to an archetype or an architecture and then don't have a way to actually solve that problem. Or they just make it harder, because there's almost always a way to solve the problem. It just may cost more weight, or just may be more complicated, less reliable, all things you don't necessarily want. And so throughout that week, we're kind of setting up, my role on the team is to be the project manager, moving the robot through the whole season. And so part of that is kind of setting up, okay, where or what are the things we need to know to be able to make some decisions pretty quickly, that we're okay continuing to move down some path. And so a lot of what we're doing is confirming assumptions where we say, okay, we think we can package an intake into this 3 inches past the frame rail. What do we need to see or know to be able to know that for sure? And that was pretty much what we were able to get to on day 8, where we built it all and like the note went up. We're like, okay, we think we can get this fast enough and we think we can improve it enough to make it work. Because if that doesn't work, and then this has to be 4 inches, the whole rest of the robot changes. Like you can't package the other things in there. It just doesn't, or not easily. We get a bunch of other trade-offs. And so we have to know those things before we're able to commit to that design and moving it forward. Yeah, so we're trying to figure out what do we actually need to test to be able to make our climber intake, whatever it is, and be pretty happy with it. You're never going to be perfect. There's always going to be a harder problem coming up. You're like, oh, this is super easy. The climb's just going to work. And then you don't trap at all your first event like we didn't. And then it took a long time to figure out why the climb was not doing what we wanted. But we were able to solve it then eventually, and it did work. But we're working rapidly towards those decision points because those are the things that we need to get tested, get built, get everybody on the team comfortable and happy with what we've learned so far about the game and what we've learned so far about the robot that we have, to be able to say, yeah, we're still on that right direction. Because at this point, even day 11, we could have very easily just been like, oh, no, this is all terrible. We're doing something else, right? And some of that always happens as we're going through other teams' things. We're like, ooh, actually this year specifically, I don't think I have the picture in here, but like the version of this sketch, one version earlier was basically a sketch that Wildstang put out to actually get us there. Because if they didn't have that one, we wouldn't have had this one. There's enough differences there that this one doesn't quite do the same thing, but they're pretty close. And they immediately kind of went off in a different direction. And that was a big conversation with us, was like, oh, they went a very different way. Are we doing it wrong? And so some of that is just trusting, no, we think this actually is correct. This is doing what we want it to. Our prototypes are pretty good. One of the things I want to talk about is nowhere in here did we show a prototype launcher. That was kind of intentional. Launching a note seemed like there were just going to be a lot of solutions. So it wasn't the problem we really needed to solve because we knew other people were going to solve it. So early on, we were able to just kind of sketch whatever, and it would be okay. So like some random circles and enough space, we were like, hey, there's a notes width there somehow, there's some wheels. There will be a launcher that fits there. And if ours doesn't work the first time, we can copy somebody else's. So we were putting a ton of work into the other stuff that was hard in the game because we knew the launcher stuff would be okay. Like we didn't have to do a ton of work there. So like our first, I think we had some weird horizontal terrible thing. It was
the underwheel one.
Oh, the underwheel one was real bad. Like so many of our launcher products were just because we were not really focused on it at all.
Did it help that that was the mechanism that first gave us as well on day 1 with the kit file?
No, because we knew that was not very good. We knew we weren't doing that. Like, you know, at a minimum, you needed wheels on the other side. Like having it arc, like that angle was never going to be controllable, like from a distance at least, right? That was part of that is understanding the high level game, right? And some of that we didn't necessarily get right. But it's like, okay, where with our field kind of built, we taped some stuff off, we had the stage. That decision point of like, hey, where do we actually need to shoot from to be elite was a lot of talking. Like, it's like, do we need to be from this stage leg, from this stage leg, from half court? Like, where is it? And so we were like, okay, half court, no, like some teams have videos of it, but I don't think anybody was doing it super reliably. A couple teams did it okay. But kind of into the wing line was our goal. And as long as our launcher could do that, we were pretty satisfied with it. And that took, I don't know, week 3, 4 before we had something that was actually doing it.
Today, there's been a discussion of this dividing line between the skills of the mentor, probably having an optimal solution, and the high school students who are being handed this problem and being high school students. This balancing.
So the number one problem is you think the mentors have an optimal solution. They don't. What? Yeah. That's the first assumption you need to fall back on. Nobody has an optimal solution. FRC is incredibly hard. Like, yeah.
Watching, even if you think you have the optimal solution, students are trying to figure it out. They're 15, 16, 17. they're here to fail. I don't mean that in a bad way, but they're here to try and build stuff. To what extent do you watch them in the first week saying, that's not
Fair-
go for it?
No. So we're guiding them on what to build because the failure's gonna come. We don't have to let them fail. If you're in FRC, you're gonna fail. Like you can try to protect against it as much as you want. You're gonna fail constantly. Like all of these prototypes we build, we're setting them in directions. We're like, hey, we need to build this thing. The first versions of them are terrible and they don't work at all. Like they have all the failure they need, even with as much guidance as we can possibly give them. They're gonna fail constantly throughout that whole process. We don't have to let them fail ever. It's gonna be there no matter how hard we try to avoid it. Like it is just there all the time. Like every event, like every time, no matter how much we're trying to make sure there's never an electrical issue. We found a new one with like a USB crazy thing where the whole RoboRio USB bus lost power and things, but it still thought it was up, and every CSA can't find it. And it was a mess. Like the failures are going to be there. Yeah.
But then saying, this is a couple of us put this idea together. We want to build it, and letting them build that, or just saying, no, it's going to fail for these 5 reasons. I don't.
If we know it's going to fail, we don't have a reason to put the resources to it.
So
Like,
it depends on how much.
we are limited in time
For something.
And-
So a lot of times with the students, all of this is a discussion, right? So we're talking about it so constantly and showing them videos, and they've looked at past robots and all of these things that for the most part, it's pretty easy to get everybody moving in the same direction. There are a few times where we've had students been like, no, this is definitely the way. And for the most part, we have enough resources where if they want to grab a couple kids and run off and do it and get to a point of proving it or have the discussion and talk it out, we definitely can. But most of the time it ends up being a single student away from the rest of the group who's all trying to move one way. You don't ever want to have like that student slow down the whole rest of the team who's kind of understanding, oh yeah, we've tested these things, we've seen this, we've seen these other teams do it, and we kind of have a concept of how it works. Like every once in a while, especially it depends on who the student is too. So right, if it's one of our seniors who knows a ton and can do all the CAD and is like, no, I absolutely believe this. Yeah, we're gonna empower them to do all of the stuff. It's a random freshman who I've seen 4 times before kickoff. I don't really care that they really want to build a turret. Like they don't know enough to know why it's bad yet, or why we don't have the resource to do it. So it's fine that they want to, but we also have Photon for that reason where they're kind of able to do things. The students are all very quickly empowered to be able to run the 3D printers and the laser cutter and things. And so we'll walk them through and be like, oh yeah, you could do this. If they really want to, they'll build something. It won't be very good. And we're like, that's kind of what we're looking at. Or we'll show other past robots. We're like, yeah, this robot worked great with a turret. And then I'll go pull up videos of all the ones that work really badly. And so you have a lot of those examples from the past where we don't really have too much of that problem with students demanding that we go one direction, especially if they're students who have already been working with us for 3 or 4 years. They've had the same past experience of past robots. We're like, oh yeah, we shouldn't do that thing we did in 2023, right? That was bad. Like we all know what happened then. And so they were all building on that same experience for their time on the team. So we don't have to really drive too hard and tell people no, because for the most part, they have pretty good ideas where they're like, ooh, what if we had a powered roller here? And we're like, yeah, like that was one of the, they're like, we need something slippery or powered on the back of the trap thing. And that one of our students had the idea and it was like, oh, that's absolutely, let's figure it out and test it. And we did it as soon as we could. I think we'd like tape some Teflon sheet to it the first time, like whatever the quickest way we can to test something, we will. They're like, that was awesome. And then they went in and catted it to make it a powered roller and they got our trap to work because they built the trap cape. And so a lot of times the students' ideas are very much in the path because we've already set the direction for them and they're able to get the ownership and the idea right because we kind of all know, not even for them, with them, we've set that direction, we've talked about it, and we kind of know where we're trying to get. And so they're all of their ideas are moving us in that same direction. Oh yeah, so a couple things. We don't vote on anything ever, basically. Pretty much, I don't remember the last time we voted on something as a team. Consensus building as much as possible. If for some reason we absolutely can't, we'll talk to the couple holdouts and be like, hey, what's going on? But like, we try as much as we can to be like, hey, if you think we're really wrong somehow, talk to us for as long as you need to. And like, maybe you can convince us or the rest of the team that we're doing not on the right track. But we normally get there to where the leadership, the student leadership, and the mentors are all kind of pushing in that same direction. And we don't have to try to vote or anything. We're not split on how we're doing things. A lot of the older presentations talk about weighted decision matrices where you like assign values to things and choose the best way based on that. But I've been in enough of them where I can like choose the weights to just get to the thing I want at the end, and that's not a good way to make decisions. So we don't do that because I'll win. And so like that's not a good way. I don't want to win all the time. I want to get to the right option. I don't want just the thing that I think is right. There's a lot of push to decide on design early. There ended up being a running joke with our lead designer last year, where she would come to me and be like, "Hey, we sketched out this thing. It works. This is what we're building, right?" This is like day 2. I was like, "No." And then that would go on for the next 11 days. Like every day, it'd be like, "This is what we're building, right? We have a robot? No, we don't have a robot." And you keep going, and like you're like, "This does work." And I had multiple. I don't know. We probably had like a Rika moment every like I don't know day, 2 days. Like this design is great. It's perfect. And you draw it up, and then we're like, "This is what we're doing." And then we're like, "Why is it bad?" And then we quickly realize why it's bad. And then we keep going back to the drawing board and try to make a new robot or a new architecture. But there's so many times where I'm like, yeah, this is absolutely great. Or a student comes in like, what if we did this? And they're super excited about it. We're like, okay, why is it bad? And then we go through and we find why it doesn't work, more importantly than why it does work. Because there's a lot of robots that can do things. There's so many different ways to play the game. You can make a lot of choices early and still build an elite robot, right? There were robots this year that were 20 by 20 frame perimeter and weighed like what 85 90 pounds, whatever Barker was, and was a very elite robot. There are robots that are 120-inch frame perimeter and weigh 125 pounds and are also elite robots. And so you could decide either one of those for most games before you ever see the game and still come out with something very good. It's just what is optimal for your team and your resources and how you want to play the game or how you see the game is things that you have to decide for yourself. But there are so many different ways to play the game at a high level. And a lot of that is just things that are sometimes out of your control, right? International teams have to like fly with their robot, so they need to build them smaller. So if they want to put them in like a suitcase, yeah, whatever your constraints and resources are things that I don't know. You were there with your students, with the people, their mentors. All of those things can be tweaked and worked through and still get to a really good outcome, even if it's not the same thing that we would do. Like all your tools are different, your experiences are different. But there are some things we're not going to solve in software because we're not that great at it. So we'd much rather do it in hardware. Okay. Anything else? So yeah, so day 11 is when we get we're pretty sure we have the architecture right, and we go through the design slides with students. We can pull some. Let me switch over to here. Okay. So if anyone wants to go through the deep dive, you can read through all of the blog posts. Here's the one I actually want. Oh yeah, so that's that was the pre-concept that we thought was pretty close. And we'd like the launcher feeding into this, but we didn't quite like it. That handoff was going to be tricky. It was going to take too much time more than anything else to be able to do it. We wanted to be able to have the amp move a little bit faster so we could amp in like sub 3 seconds. A lot of things when we're talking about like what it means to play at an elite level, we're talking about how long does it take to complete a task. So like our trap this year, when we said trap or not, what we actually meant was sub 5-second trap or not, right? Like if we couldn't sub 5-second trap, our robot wasn't going to trap. And so it was how much belief do we have that we can actually get it to do that thing. It didn't do that till pretty late in the season, but we eventually got it to work. Let's see where we're at. Yeah, so that's alpha. And I think that was I was going to say that's day 10. Yeah, so this is day 10. So day 10, we started having a CAD of alpha. And so I guess we had some idea of a framework in there. Yeah, the launcher is just random plates. Yeah, the amp trap is just an elevator that we were able to sketch in and make sure that it would actually reach roughly the height we thought it could. We had to figure out how the rollers actually worked to do that. And this is the alpha robot, right? So this is going to be built as fast as we can and never see an actual field. It's going to be built very poorly. It's going to be held together with a bunch of plywood. That's all laser cut. But it does serve the purpose of getting us a test bed pretty quickly. Yeah, and the programmers are able to do things and have a lot of testing with it as well. Ideally, sometimes we don't necessarily want to build a full alpha. We want to build it on top of like a pre-existing chassis. This year we couldn't because of the way the intake needed to work. Yeah, so we started laying out on day 11. We were able to be like, okay, we know we have these 5 subsystems. We were able to kind of assign our mechanism leads to these. We already had a rough idea for some of them at this point. Like our launcher lead was working on launcher stuff well before this, because we knew she was going to do that. Some of the other people we were moving around still because we didn't know what mechanisms were going to be on the robot. And so this is kind of where we were trying to get to be able to do the rest of it well. And so a lot of this is like, it looks a lot more complete than it is. This CAD is very, very fast and on shape. This did not take a ton of time to do. All this is just tube converter, feature script stuff. That first intake we did on day 8, it's basically just like, how do we get a belt and some gears here? And there's some bad, weird 3D print stuff here that we knew we were going to iterate on all season that we ended up only doing one more iteration. Shockingly, we definitely thought that was going to be a lot, and it wasn't. Yeah, launcher is a mess still here, but we knew we were starting to figure out what a pivot looked like. This was the alpha version of it, so we just threw a Max Planetary 90 gearbox on it, and we're able to pivot it just directly on the hex shaft, but it worked well enough. It had a ton of slop in it, but it was alpha, so we weren't trying to be super accurate yet. Yeah, amp and trap, we knew we needed to build something to be able to actually test it on alpha to make sure it would actually get the heights we wanted. It knew it didn't have to work perfectly. Okay. Oh, my bad. I told you I could go an hour on every slide. I keep going. All right, thank you, everybody.